I'm going to do a quick explanation on how volcanoes are actually formed. There's two different types of boundaries we're going to talk about. The first boundary that we're going to talk about is a convergent boundary. Remember, a convergent boundary is where two plates are coming together. In this instance, we have one plate that's here, and that's coming into contact with the other plate that's over here. Now, this plate is going down underneath, and as it gets closer to the center of the earth and more pressure is building up on it, it is getting hotter. It is getting so hot that the rock is melting. Now, whenever you melt the rock, it becomes less dense. And if you remember from last year, things that are less dense have a tendency to float. So the magma starts actually working its way up to the surface, and it comes through at these different parts and build up volcanoes. If I were to show you on our little, sorry about that, there we go, on our simulator, it would be closest probably to this one. I don't like this one as much because it's showing that they form out in the ocean, and that's not always true. There are actually quite a few volcanoes that are on the west coast of the US, um, in Canada and Mexico and all the way down through South America, um, because we have this Pacific plate that is going underneath the other plate, which creates these volcanoes. So if I go to 20 million years and I run this, yes, we have the earthquakes and stuff, but you can see the plate that's going underneath. You can see where we have the magma melting, and you can see all the little volcanoes that are popping up because that less dense magma is rising up to the surface, and that's creating volcanoes. Now this can happen whenever the ocean plate is going underneath of this other land plate here. This is just the example that they have. Another example of a place where volcanoes can be made is along a divergent boundary. That's whenever it's separating. So the two plates separate, and this magma is actually squeezing up in between, and it hardens, and that pushes the plates apart. So this divergent boundary is shown in your divergent boundary. So I'm going to go ahead, click it to 20 million here, and run. Now, as I run this, you can see right here the crust is getting a little bit thinner. You guys can see the less dense magma that's going to be going up in between. Not always does water get involved. We have water that they're showing here, but that isn't an absolute necessity. You can see the volcanoes that are building up along here. So that is a divergent boundary. So you can get them at convergent boundaries and divergent boundaries. Notice I didn't say anything about the transform because you don't get them at transform boundaries. Right here, I have a map of active volcanoes in the world. So you can see we have quite a few different ones that are being monitored that are here in the US. You can see that there's quite a few up here as well, quite a few in Alaska, all the way down. And there are more that are in Japan things, but because I'm using the USGS, United States Geological Survey, it only has the US ones really that it's concerned about. But this area that goes all the way around the ocean here that has these volcanoes and have earthquakes and things, that's called the Ring of Fire. Basically because of all of the geologic activity that happens in the area. Another place where you would have a lot of activity would be right here on the Mid-Atlantic Ridge. This is an example of a divergent boundary. So, like for instance, up here in Iceland, they actually have quite a few volcanoes going on up there. And you can see, let's see if I can zoom in a little bit here. There we go. Give it a second to catch up. Um, you can basically see this line that's going down the center of the Atlantic Ocean. And this is the Mid-Atlantic Ridge. And this is where magma is coming up from the center of the Earth and pushing the plates apart. And this goes all the way down, and it's just this big ridge of volcanic activity. But it's underneath the water, so we don't see it or hear about it that often. Um, but that's how volcanoes are formed. If you have any questions, make sure you raise your hand. I'm happy to come